Assalamu alaikum, Hassan Turmus, Al-Mahdi Schools. Today we will start by part 3 from the numerical warm-up. Objectives: define an interval, represent an interval in set form and on a number line. Find the center and amplitude of an interval. Materials: we needed rough papers, pens, calculator, textbook, and copybook. Intervals in R. Notion of interval. On x-axis x prime or x, A and B are 2 points of abscissas A and B respectively. M is any point on x-axis whose abscissa is x, and here's the figure. If M belongs to the segment AB, then the abscissa of M is between the abscissa of A and abscissa of B. Then x is between A and B. We translate this double inequality by writing x belong, open bracket, A semicolon B, close bracket. This notation is called an interval. Notion of interval. Here we will talk about the structure of an interval. This is the interval I. The name of this interval may be I, J, K, and any letter. These the two brackets. And here we have a semicolon between A, the lower bound, and B, the upper bound. Notice that we have infinity of numbers between A and B. Types of interval. Closed interval. I equals AB. All real numbers from A to B contained in I, including A and B. For that, we draw the bracket into A and this bracket into B, because A and B belongs to this interval. Open interval. We write I, open the bracket away from A, and open the bracket away from B. Here, all real numbers from A to B contained in I, except A and B, so we exclude A and B. Semi-open, semi-closed interval. We have two types. One of them is open at B and closed at A. The second one is closed at B and open at A. Here, all real numbers from A to B contained in I except B, and here all the numbers contained in I between A and B except A. Remark, the symbols plus infinity and minus infinity do not represent real numbers. So, if an interval admits an infinite bound, we have to open this bound. Example, at minus infinity or plus infinity, we should open the brackets, so we draw these brackets away from the infinity. Set form. Here we have in this column the set form, and here the notation of the interval, and here the representation on the number line. I have 4 remarks here. First, if we have less than or equal, we close the bracket. If we have strictly less than, we open the bracket. And if we have greater than or equal A, or greater than A, this means that A is the starting point, so it is the lower bound, and the ending point here should be infinity. And if we have x less than or equal A or x less than A, this means that A is the ending point, or it is the upper bound, and the starting point will be at infinity. Finally, if x belongs to R, then the interval will be minus infinity plus infinity, all the real numbers. Example 1. Write each of the following sets in the form of interval, then represent it on a number line. Part 1. E is from minus 4 to plus 3, and we close the brackets, and here we plot the points minus 4 and 3, and we draw 2 continuous lines and then shade. Here we solve this inequality to get x greater than 3. This means the interval will be from 3 to plus infinity. We draw the number line, plot the point. Here we draw a dotted line, not continuous, then shade to draw G. Application 1. Stop the video and try to solve. Definition 1. Intersection of two intervals. Let I and j be two intervals. The intersection of these two intervals, I and j, is the set of real numbers that belong at the same time in both, and we write I inter j. The intersection of two intervals may be interval or singleton or phi. This remark is to illustrate the definition. If we have a number line here, we draw the interval I in pink and the interval j in blue. The common region between I and j is the intersection of these two intervals. For that, we say the real numbers belong at the same time for both. This means the common region. And here we have a new interval for the intersection, starts at this point and ends at this point. Example 2. Find the intersection in each of the following cases. We have I and j, we draw each of the following intervals, then the common region is the intersection from 2 to 4. Here, we draw each of the following intervals, but there is no intersection. This is the case of no intersection, so I inter j equals to 5. In the last example, we draw I and j, there is only one common point, which is 4. So I inter j equals singleton 4, since 4 is the only number that belongs to I and j at the same time. Application 2. Stop the video and find I inter j. Definition 2. Union of two intervals. The union of two intervals I and j is the set of real numbers that belong in I or j, and we write I union j. The union may be interval or union of intervals. This remark is to illustrate the definition. Here we have a number line, we draw I in pink, we draw j in blue. Here the intersection, common region. Here the union. The union represents all the numbers that maybe belongs to I or j. So any region on the number line colored by either I or j, we take it in the union. Example 3. Find the union of the following intervals. I union j, this is I and j, and here the union from 1 to 5. Here I and j, the union is all the region marked by either I or j. And here I from minus infinity to 5, and this is j. All the region from minus infinity till 10 is the union. Application 3. Stop the video and try to solve. Center and amplitude of an interval. If I is an interval of closed or open bounds a and b, where a less than b, then we call the center of I the number c, b plus a over 2. We call the length or amplitude of I the positive number b minus a. The half length radius of I is the positive number r equal b minus a over 2. Remark: every interval of the form c minus r, c plus r is called a centered interval. Example 4. Find the center and radius for each of the following intervals. Just apply the rule. For the interval I, we have this is a and this is b. So c equal a plus b over 2, we calculate to find 9. R equal b minus a over 2, we calculate to find 3. J, same as I, and k, here we have a equals to 4 and b equals to 10, then c equals 7 and r equal 3. Application 4. Stop the video and try to solve. This is your assignment. And this is the summary of the first part. This is for the second part, and this is for part 3, which is our part now. We have 3 objectives next, and thank you for watching. Wassalamu alaikum.